We often assume that finding extraterrestrial life is a matter of pointing a telescope at a distant blue marble and waiting for a signal. In reality, the universe is a gauntlet of lethal environments. Most planets instantly crush, boil, or irradiate any biological material on their surface. Earth exists because our solar system is an anomaly. Our Jupiter stayed in a stable outer orbit, but in most systems, gas giants migrate, destroying everything in their path. Hot Jupiters form far out, then spiral inward. Acting as gravitational wrecking balls, they swallow rocky planets or fling them into the void. Near the star, temperatures exceed 1,000 degrees Celsius. Supersonic winds whip through the atmosphere, driving sideways storms of molten glass. When rocky worlds are pushed this close to a star, they become lava worlds. The heat is so intense that solid continents soften and collapse into a global sea of liquid magma. On the day side, stone evaporates into the sky to form glowing clouds. As these clouds drift to the night side, the vapor cools and falls back to the surface as solid rock rain. Because standard planetary mechanics actively destroy stable environments, the search for life has become a hunt for the universe's rare geographic exceptions. Heat is only the first filter. Even at a safe distance from a star, a planet's core composition can create a lethal environment through extreme chemical pressure. In systems with more carbon than oxygen, planets become giant pressure cookers. On a carbon planet, the ground is sharper than broken glass, the sky is a methane fog, and the rivers are made of heavy black grease. Internal pressure creates radiation hazards. Inside ice giants, molecules are ripped apart, warping the magnetic field, tilting it 50 degrees off axis. This leaves the planet unshielded. Solar radiation effortlessly bypasses the defenses, slamming into the atmosphere without warning. Gravity itself can prevent biological development. Circumbinary planets are caught in a constant tug-of-war between two different host stars. This orbital chaos creates a cycle of unpredictable seasons and shifting light levels. Temperatures never stabilize long enough for complex chemistry to take root. These lethal filters rule out the majority of planetary models, forcing astronomers to search for highly specific structural anomalies. Identifying worlds that bypass these filters requires more than visual observation. The James Webb Space Telescope hunts for specific chemical signatures within distant atmospheres. One anomaly is the super-Earth. These massive rocky worlds have enough gravity to hold on to a thick, rich atmosphere that acts as a shield against stellar radiation. Another exception occurs on eyeball planets. These worlds are tidally locked, with one hemisphere permanently facing a scorching sun, while the other remains in frozen darkness. Life cannot survive on either extreme face, but a narrow temperate ring exists between the fire and the ice. In this permanent twilight band, temperatures are stable enough for liquid water to pool. Astronomers are also looking beneath the surface. Deep, pressurized oceans can exist entirely sealed off from the vacuum of space. On these ocean worlds, the weight of the water creates a mutated form of ice called Ice 7. This substance stays rock solid even at temperatures that would normally boil water. Deep-sea ecosystems could exist in the darkness between this boiling ice floor and the heavy water above, completely isolated from their host star. Habitability is often found in these slivers, hidden miles underground or across a twilight strip only a few hundred kilometers wide. The conditions for life are pushed to a different extreme when a host star is removed from the equation. Billions of rogue planets drift completely alone through the freezing space between galaxies. Without a sun to orbit, they exist in permanent, absolute darkness. Even in the void, internal heat can keep a planet alive. Thick outer shells of ice provide enough thermal insulation to maintain liquid oceans in the core. Other worlds orbit dead stars. Pulsar planets are stitched together from the radioactive ashes left behind after a supernova explosion. The most extreme environments are planets. These worlds form within the violent rings of dust swirling around supermassive black holes, relying on superheated gas for light rather than a living star. Astronomers are identifying the universe's most resilient survivors, often hidden within its most violent cosmic horrors.